Sorry, what you?
I am doing that. I will post. So the problem is like I cannot post that assignment.
So you will not able to post that assignment. Okay, fine. Mm, okay, fine. Hello. We will now let us. Can somebody please remind me of the formula for relative lowering of vapor pressure that we derived in the last lecture? What is the relative lowering of? What is the expression for relative lowering of vapor pressure? Yes, Mariam.
So P naught A minus PA divided by
Yes, yes. Go on.
correct? Divided by not correct.
Can you all hear me properly?
Yes, sir.
Yes, sir.
Okay, but I guess there was some cuts in Mariam's voice, right? I mean, it was not audible at few instances to me. I hear till here P naught A minus PA upon. Yes, can you, Sania, can you tell
Upon PA.
upon PA? Okay. Now it is equal to, tell me, Sania, it is equal to what?
X.
It
I
is,
mean
it is equal to
X
chi B.
chi B, yeah, chi.
It is equal to chi B. Okay. And then at the end, we derived at the relationship between molecular masses and the vapor pressure, and it was P naught A minus PA upon PA. And this was equal to what? This was equal to the given mass of B upon the molar mass of
Molar mass of
B into
A.
the molar mass of A upon the given mass of A. Okay. Amalia is also here. Good evening, Amalia. Okay. This was the whole.
Good evening, sir.
This was the whole relationship that we came up with. We didn't do any questions for relative lowering of vapor pressure. Okay. So just to revise this down, then let us do a question. And the question has vapor pressure of pure benzene. Now it is given that vapor pressure of, this is a question, let me put it in some color. Question is vapor pressure of pure benzene is 0.850 bar. It is 0.850 bar. And there is one non-volatile, that means solid, a non-volatile, or any solute which does not have vapor pressure. Non-volatile solute is added. A non-volatile solute is added weighing. Let us take 0.5 grams. 0.5 grams. 39.0 grams of benzene. 39.0 grams of benzene. Okay. Now the vapor pressure was found to be vapor pressure was found to be, now vapor pressure of what? Vapor pressure of solution. Vapor pressure of solution was found to be 0.850 bar. Sorry, this is the same thing. 0. Let us decrease it a bit. 0.845. Let us take 0.845 bar. You have to calculate what? Calculate the molar mass of the solute. Okay, easy question. Direct formula, right? What will be the molar mass? Just see this, P naught A minus PA upon PA will be equal to WB upon MB into MA upon what? WB. Here, what is P naught A? P naught A is the vapor pressure of pure benzene.
Pure benzene.
Pure benzene. Okay. What is PA? PA is the vapor pressure of solution.
Solution.
Right? Vapor pressure of solution. Now, similarly, what is WA? Sorry, WB will be the mass of solute. Okay. Now, MB we have to find out. We have to find out. Next, what is there? MA. MA will be molar mass of benzene. Now, WB will be mass of solvent that we added. What is solvent here? That is benzene. Simple question. And good evening, Ahmed.
Good evening, sir.
Okay, we have just started. I mean, in the previous slide, there is nothing but just a revision of what is the formula for relative lowering of vapor pressure and how we can find the molecular mass by the vapor pressure, relative lowering of vapor pressure. And this is a question. We didn't do any question in the last lecture, no? This is a question for relative lowering of vapor pressure. Try this out. Okay, just try this out. First of all, find the molar mass of benzene, right? Because you don't know the molar mass of benzene. Find out the molar mass of benzene. What is the formula for benzene?
C6H12.
C6H.
H12.
H6.
Yes. H6,
Yes.
not H12. C6H. What will be the molecular formula then?
The molecular formula is C6H12.
Oh, sorry. What will be the molar mass? Sorry, molar mass.
6 into 12 plus 6. 6 into 13.
72 plus 6, right?
Yes,
Yes,
sir.
sir.
78.
78 grams per mole. Okay. And you just have to plug in the values. You know what is P naught A? P naught A is this value. What is this? What is the vapor pressure of solution? Vapor pressure of solution is also given. Just plug in. Tell me the answer. You can rearrange this as MB will be equal to
Sir, WV is 0.5.
yes, we added 0.5 gram now. Solute, we weighed 0.5 gram and we added it 0.5. Yes. Okay, wait a second. This will be A, WA and not B. This will be WA. This will be WA. Put your answer on chat, okay? If you get the answer, put the answers on chat. Just wait a second. This will be P naught A and not PA. This will be P naught A. Okay, this will be P naught A. Relative lowering of vapor pressure. This is P naught A. 4, 5, and 2. Anyone? No one? Answer. So simple calculation, I guess.
It says 0.7, 0.170 something.
0 point.
No, sir, 170.
170 as the answer, no? 170 grams per mole will be the. Okay, did anyone get this answer? No? Ahmed, you can unmute yourself.
Sir, I got 70.
Ahmed, can you please unmute yourself?
Yes, sir. Hello?
Yes. I'm asking you to unmute. Sorry,
Yes,
mute
sir.
yourself. Sorry, mute yourself. Sorry, mute yourself.
Okay.
Not unmute, mute yourself. Okay. Sonia, where did you mess up?
I don't know, sir. I'm seeing again.
This was simple, I guess. Wait a second. We had MB is equal to what? MB is equal to. Okay, let me take that P naught A formula. P naught A minus PA upon P naught A is equal to WB upon MB into WA upon, sorry, not WA, MA upon WA, MA upon WA. Now we have to find what? We have to find MB. So MB went there, and the P naught A minus PA will come down. This P naught A will go up. So we'll be having P naught A into WB into MA upon, we have just WA here, which should be multiplied by P naught A minus PA. And since these are in, this whole term is in numerator, all will come down, and we will have a bracket here. Okay, now what is P naught A? P naught A is given as how much? 0.850 bar. Okay, into WB. WB is given as how much? 30. Sorry, not 39. It was given as 0.5, right? 0.5 grams into molecular mass of A is 78 grams per mole. Now this all will be divided by, This all will be divided by WA, which is 39 grams into P naught A minus P naught B. This is equal to how much? This is equal to 0.850 minus 0.845, both in bars, both in bar. So we can say this gram and this gram can cancel out, this bar and this bar can cancel out, and we will get a gram per mole in the answer. Now you can see 39 2s are 78. Okay, 39 2s are 78, and just okay, fine. I guess 0.850 into, there is something. Okay, now here we have what? 0.005. Okay, 0.005. Now 0.5, I can write 0.5 as 1 by 2. So I'm just writing into 1 by 2, and into we have 2 here. So this 2, 1 by 2, and into 2, this will multiply and this will become 1. So you don't have to worry about that. This gram per mole is still there. We have just 0.850 upon 0.005. You can write this as what? 850 upon 5. That means you have multiplied 1000 on the both side, numerator and denominator. And you, if you see this, 5 ones are 5, then you will get 35, then 5 sevens are, then zeros are, and you will get 170 gram per mole. Okay.
Yes, sir, got it.
Got it. What about Amalia?
Yes, sir.
Okay, you got the answer.
Yes, sir, I got the answer.
Okay, fine. Now you can, those who have not got the answer, you can copy this. If everyone is done, just please raise your
Yes,
hand.
sir.
Sir, done.
Done.
Sanya also done. Okay, fine. Now let us look at a different colligative property, which is known as elevation in boiling point. It is known as elevation in boiling point. Elevation in boiling point. Okay. Now one by one, I will ask you, what is boiling point? Okay. Yes. First of all, Ahmed, what is boiling point? Can you define it? Can you tell me something about it?
Yes, sir. And the point at which any substance or liquid starts evaporating.
Starts evaporating.
That is the boiling point of that particular object or material.
What do you think? What is the boiling point of water?
It is 100 degrees Celsius.
100 degrees Celsius. Okay. Boiling point. Now, if I spill some water in my floor, if you spill some water, if anyone spills some water in the floor, will it start evaporating slowly?
Yes, it will evaporate.
So, but the temperature is not 100 degrees Celsius.
Yes, it is not.
Okay, fine. You think about it. Okay. Next, Amalya, what do you think? What is boiling point?
Boiling point. It is the point in which the temperature where vapor occurs.
Vapor occurs. Okay. But if you keep a bowl of water, if you cover that bowl of water for overnight, then you will get water bubbles on the top of the lid, na? On the lid. That means it became vapor. Okay, fine. Think about it. Next, Mariam.
Sir, it is the measure of temperature at which the water evaporates.
And how evaporates? If you spill some water, then it's evaporate in room temperature also. Even if you
Yeah.
turn on the AC, after some moment, it will not be there. So
It does not have a particular temperature all the time.
the boiling point is not 100 degrees Celsius for water.
It is, but like it will evaporate eventually.
Okay,
It takes
fine.
time.
No, wrong answer. Sanya.
It is the temperature at which something boils,
Something boils
like liquid.
at which something can heat. Okay, fine. Now let us do a thought experiment. Okay, what is a thought experiment? A thought experiment is something in which you don't have to go to lab or something. You just sit in your table and you just start thinking of things and you think what will happen if this happen and that happens. Okay, so just imagine every one of you all are in kitchen. Done? Raise your hands. Okay, this will be fun. Raise your hand. You are in kitchen and you have. Okay, fine. You are imagining yourself in kitchen. Okay, fine. You're imagining yourself in kitchen. Then you took a bowl of, I mean, you took not a bowl of water, but you took an utensil and in that you poured some water. Okay. Then you took a lid and covered it. Turn on the gas stove or whatever you have in your home. If it is induction, that is induction. You just put it with on some heat. You started heating it. Okay. You started heating it. Okay. Now lower your hands. You started heating it. Okay. Now, Ahmed was the first one. Ahmed, can you please unmute yourself?
Yes, sir.
Okay, I guess you cannot unmute yourself. Okay, can I have
I
somebody
can.
who's having a? Actually,
I
you can.
can.
Okay, fine. Okay, then you have the lid covered. You have the utensil which is covered, lid covered. Okay, but the lid can open. It is not tight. It's not airtight. Okay, it can open. It's not a cooker. Obviously, it's not a cooker. And I asked you, ki, when it boils now, just call me. But you don't have to look. You don't have to open the lid. Okay. You understand the rule, everyone?
Yes, sir.
Everyone understands the rule now? Please raise your hand if you understand it. You have to tell me when it boils, but you don't have to look at it. You don't have to open the lid. Okay. Now, please lower your hand. Please lower your hand. Okay. And you are sitting far away. You cannot even go near that. You can hear it. You just can see the utensil and you can just see that, okay, fine, stove is on, it is burning and it is heating the utensil. Okay, now raise your hand if you can tell me at exact point when it is boiling. I mean, not exact, but you can say, okay, now it has started boiling. Okay, Mariam can tell in, okay, fine. Anyone, Ahmed can also tell when it will boil. Okay, fine. Amalia will also tell. Okay, fine. And I cannot see, wait a second. Okay, Sania. Sania, you cannot tell when it is boiling. Okay, fine. Mariam, tell me, how will you tell?
The
How will you know?
utensil will shake and the water will come out.
Utensil will shake or the lid will shake?
Yeah, both. Like the lid will shake and the water will come out.
Lid will shake. Achha, water will come out. I don't know. It had mostly happens with milk. Okay, what about Ahmed? Same thing. Lid will start shaking.
No, sir, since you said the lid was not airtight container, so it will actually evaporate some water out of it, and I will be able to see this vapor, I guess.
Achha, you will be able to see the. I'm saying it is covered. So if it is not even if it is not airtight, but it is covering it. So if you have to see the vapors, the lid has to shake a bit, and then only it can. What about Amalia? What did you have in your mind? How will you tell me?
You can hear the bubbles.
I told you are sitting far away. You cannot see it. I mean, you can just see the utensil, not hear anything there. Okay. Yes, Sania, can I have you now, please?
Yes, yes.
Hmm. You tell me. You didn't know how to. You will have
Uh,
a
uh,
you have a utensil, and that you have water, right? And you
yes.
have a lid cover, and you have a lid covering it. And this lid can obviously it can shake and all, but it is not airtight. But it is covering it wholly. It is covering it wholly. I mean, generally we have these type of things now in which we make tea and all. So we cover it, that lid, that kind of lid. Okay. And after heating, what will happen? This particular thing will start to shake.
Shake.
Yeah. This
And
will start.
vapors come out.
This will start to shake. Now, how to show you shaking? This is shaking. Okay. Now, why does it shake and why it was not shaking previously? Amaya and Mariam, you can lower your hands. Yeah. Now
Because
can I?
they
Hmm.
because
Yes, tell
it
me.
just started burning the
So what
first one.
happened? But why it was What is
Because
the
The
difference?
vapor is applying pressure on the lid.
Exactly, correct. What happens when we start boiling, and we have learned that when we start heating any liquid, the vapor pressure will increase, right? The vapor pressure will
Yes.
increase. Now, what is holding this lid down here? What is holding this lid
Pressure.
down?
Vapor
Pressure.
pressure of water.
No, the lid is held down by this
gravity.
lid is held, yeah, it is held by gravity, and there is now to overcome this. Now to overcome this, what we have to have. This is our pressure of atmosphere. Atmospheric pressure is holding that particular lid down, and when we apply more pressure, when vapor pressure, when so it will start boiling when the vapor pressure of a liquid is equal to the atmospheric pressure atmospheric pressure, it is said to be boiling. It is said to be boiling, and the temperature at which the temperature at which the vapor pressure of a liquid becomes equal to the atmospheric pressure pressure the temperature at which the vapor pressure of a liquid becomes equal to the atmospheric pressure is called boiling point. It's called what? It's called boiling point. Okay. Now, see, the good thing here is, what is boiling point? It depends on the atmospheric pressure, right? It depends on the atmospheric pressure. Now, if you boil anything, and if the boiling point is the vapor pressure is equal to 1 atm, now you say that it has started boiling. Okay. Now note this down, and please don't forget it. Okay, don't forget it. Note this down. What is boiling point? This is lid shaking. If you want to draw this, you can draw this. Otherwise, it's okay to not draw. But remember this thought experiment in your mind. Let me know when you are done.
Shada.
Okay. Everyone done?
No, sir.
Okay.
Done, sir.
Everyone. If you are not done, raise your hand. Okay, I guess everyone is done.
Done, sir.
Okay, done. Now let us look at what does it mean by elevation in boiling point. Elevation in boiling point. What happens when a non-volatile solute is added to when a non-volatile solute is added to a solvent, the vapor pressure of solution solution decreases. I mean, this is the consequence of adding a non-volatile solute to a solvent, decreases. Okay, it's added to, let me write volatile solvent, to volatile solvent. That means it is a liquid solvent. Okay, when a non-volatile solute is added to a volatile solvent, the vapor pressure of solution decreases. Now, what is the consequence of this, and how does boiling point changes if we have a decreased vapor pressure? Now, let us look at this graph. Okay, let us look at this graph. Let's look at this graph. Now, this point here, this point here that I'm going to mark as 1 atm. This is what? This is 1 atm. Okay, this is vapor pressure. Vapor pressure. This is what? This is temperature. Now let us have pure liquid here. Okay. Now this blue one, this blue mark here, this is pure solvent. And let us have green for, let us have, this green line will be for solution. This green line will be for solution. Okay. Now just arbitrarily, I'm saying that if temperature is something, the vapor pressure is here, and slowly it starts to, let me change the color. This is blue. Pure, for pure solvent, slowly it starts to move a bit up. That is, move a bit up. That is, it will reach to 1 atm slowly, like this. Okay. Now I guess it has reached 1 atm like this. This is for pure solvent. Now at this particular temperature, let me just draw this line. At this particular temperature, this is the boiling point of, pure solvent, correct?
Yes,
This is the
sir.
boiling point of pure solvent. Okay, now, yes, Sanya, you will tell me, and this is the initial temperature in which we started. This is the initial temperature in which we started. Now, at this same temperature, if we have solution, will the vapor pressure be more or less?
It will be more.
For solution?
No, less for solution, less.
For solution, it will be less, no? We just did
Yeah.
for pure solvent, we are doing for solution.
Yes, yes.
Now, the vapor pressure at this point will be a bit low.
Low.
Now you tell me, now if I have to reach with the same type of curve, now the pressure is increasing as the temperature is increasing, and we've got to a point where we have 1 atm. Let me just draw this. Now you can see, now this 1 atm has been reached by some more temperature, correct?
Yes,
A bit
sir.
more temperature than the pure solvent. Now this is what? This is the elevation in boiling point. This is
Boiling
the
point of
elevation.
solution.
Okay. Now
Yes.
this is our, what I will say about this line, this particular temperature, this is T naught
Yes.
B. T naught B. Naught means pure, and B means boiling point of pure solvent. Okay, boiling point of pure solvent. And this point here is the boiling point of solution, just shown as TB. Okay, just shown as TB. And the points here, this point, the difference here is what? This difference here is delta TB. This difference here is delta TB. Okay. Now delta TB will be equal to what? Delta TB will be equal to, which is greater, T naught B or TB? Ahmed, which is greater?
TB minus T naught B. TB is greater.
Minus, yes. TB minus T naught B. Now experiments have shown. Now when we had this elevation in boiling point, then we tried to quantify it. I mean, let us see what does it depend on in molality, different concentration terms. Then experiment showed that delta TB is directly proportional to the molality the molality of solution. The molality of solution. So they have given a formula that is delta TB is directly proportional to small m, that is molality. And when we remove this proportionality sign, so delta TB will be equal to what? Delta TB will be equal to, let us have this constant, and this will be known as KB, and this is m. Now we want to define what is KB. Okay, we want to define this KB. Okay, let me just select these, put it a bit up, just to make some space. Okay, and I can so small this a bit. Delta TB is equal to KB into M. Now what is KB? If the molality is equal to 1 for a solution with M is equal to 1, whenever you have to determine what is a constant, what does it show, what does it tell, just put the variable, in the side of constant. Like we have RHS here and LHS, we have two sides. So put this KB is in the side of M, just put M is equal to 1, then you will know what is KB. For a solution with KB, M is equal to 1, delta TB will be equal to KB. So now we have defined KB. What is KB? If you want to know what is KB, KB is the elevation in boiling point. Elevation in boiling point when the molality is 1 molar, or if you want a fancy word, we write it when the molality is unity. The molality is unity. Hence, this KB is also known as molal elevation. The molal elevation of boiling point. Molal elevation of boiling point. Okay, molar elevation of boiling point. And this molar elevation of boiling point KB, it depends on the nature of our solute. It depends on the nature of our solute. You can write this down.
Sir,
Do you have to move to previous slide or what? No. Yes. Tell me.
sir, can you explain what is KB again?
What is KB again? Okay. Please keep your mic unmuted.
Okay, sir.
Okay. We have delta TB is equal to KB into M. You understand till there?
Yes, sir.
Okay.
No.
Now we wanted to define KB. So what did we do? We can have a solution in which molality is equal to 1, right?
Yes, sir.
So just put molality is equal to 1 and you will get delta TB is equal to KB. That means the elevation in the boiling point was equal to what? That particular constant. So that constant is, how will we determine that constant? We will take one molar solution, and then check the elevation in boiling point, and that is how we define KB.
Okay, sir.
You want some more explanation?
No, it's okay now.
So the KB value is not constant, right?
It's not constant in the sense it is not universally constant. Yes, it depends on what solvent we are using.
Okay, sir.
It depends on what solvent we are using. Uh, if you are done, raise your hand. When all
Yes,
four
sir.
of you are, okay. Okay, 3 are done. Just we are waiting for Mariam.
Answer she's done.
Yes. Let us move on. Let's do a simple question on elevation of boiling point. A simple question. Then we will derive at a formula. Okay. We have glucose which is dissolved in water. We have glucose which is dissolved in water. We have what is the okay fine. Let us take 18 gram of 18 gram of glucose. I remember I asked you all in the first class, I guess. 18 gram of glucose is dissolved in 1 kg of 1 kg of water. Dissolved in 1 kg of water. Okay. Calculate the boiling point. Calculate the boiling point of solution if kb of water is 0.52 Kelvin kg per mole. Simple question. Sanya, you can. Do you have a question? Question, Sanya. Sanya, not Sanya. Sanya, you have a question?
No, sir.
Okay, you can lower your hand. Okay. We have what delta TB is equal to Kb into molality. Here you need to find what the molality, and you can rearrange. You can write the formula in this way also. You will write what TB minus T naught B is equal to Kb into molality. You can find molality, right? Molality is equal to what? Molality is equal to number of moles of glucose upon kg of water. How many kg we have? 1 kg. Okay, right? So we don't have to find anything else, just the number of moles. N of glucose is equal to given mass, that is given mass upon molecular mass. This is equal to 18 upon, you have to find the molecular mass, 18 gram upon molecular mass. You will get the number of moles. Okay. If you're stuck or something, just raise your hand. If you get the answer, you can post on the chat. Also, let me know what is T naught B. What will be the value of T naught B? I hope you all know the value of T naught B. And also remember, this is in Kelvin. So you have to Sanya, it is kb, na? Kb of water is 0. Did she give the answer? I guess she got the answer. Okay. Sanya has got the answer of del T naught B. Sorry, she has got the answer TB. TB is equal to that much. But what is the value of T naught B? And it's equal to 0.1. Yes, that is correct. Okay, Amalia has left. She got disconnected. Okay. Yes, Ahmed, correct.
So we have to,
Yes,
we
correct.
have to write. We just have to write 0.1 mole, right?
0.1 mole per kg you have to write, because
Per
there is
kg.
kg also, you know.
Yes, sir.
Yes, Mariam, are you stuck somewhere?
No, sir.
Okay, fine. Sanya, what is 0.052? What is that? Delta
So
TV?
it is, yeah, delta TV.
But we have to find the boiling point of solution. We have to find TP. We have to find this quantity. What is T naught B? Okay, fine. KB into M, you all got 0.052. And this will be in kelvins, I guess. So now tell me, TB minus, what is T naught B? Does anyone, if anybody knows what is T naught B, what will be the value of T naught B? Raise your hand. Raise your hand if you know what is T naught B. Okay, Ahmed knows. Can you post it on the chat? The value of T naught B. Will you please reconsider that value? I mean, you are in the right direction. Okay, Sanya, if you know the what is T naught B? No, Sanya, that is not right. Okay, fine. Let us have Mariam. Mariam, what is TB? What is TB?
Sir, I have no idea what's going on.
You have no idea what is going on?
No, sir.
So is that correct?
Yes, that is correct, Ahmed. Okay. Let us see the question for Mariam. Read that question. 18 gram of glucose is dissolved in 1 kg of water. Slowly, you should know that if we have dissolved 18 gram of glucose, then the boiling point of solvent will go, it will increase, it will go up. No, yes, anything, please.
Yes, it will.
Hannah, it will go up. Okay, fine. So what is the boiling point of solvent? What is the solvent here?
Water. That
What
is
is the boiling
100.
point? And what is the boiling point of, this is pure solvent, no? Pure solvent, and we represent this as what? Pure solvent is represented as the boiling point of pure solvent.
T naught B.
Yes, this is T naught B. This is equal to how much? 100 degrees Celsius. But
That
this will
is
be equal to,
273 Kelvin.
no, that is no, this will
70
be equal
Kelvin.
plus 273.15 to be exact Kelvin plus 100. This will be equal to
373.15.
Kelvin. Okay. Now, when we have got a solution, then what will happen? The boiling point will increase, and we want to find how much will increase. How much will increase? So we will write TB. We want to find delta TB here. How much will increase? So we just put that formula, that is KB into molality. Now, as we know, molality is equal to number of moles upon kg of solvent. The kg of solvent is 1 kg here, so we have just written 1. We have to find number of moles. Number of moles will be equal to 18 upon 180 grams per mole. I hope you have calculated this. This is equal to 0.1 mole kg inverse. This is equal to 1 mole. Amalia's back, kg inverse. Right?
Yes, sir.
Now, just put this in. What is KB? KB is equal to 0.52 Kelvin kg per mole. Right? And we have got molality is equal to 0.1 mole per kg. Now this kg inverse and this kg will cancel each other. Mole inverse and mole will cancel each other, and we will get 0.052 Kelvin. This is the increase in boiling point. Okay. What was the previous boiling point? 373.15, right?
Yes.
and then we will write TB, which is the
New boiling point. I
the
mean,
boiling point
for
of
the
solution.
solution. Yeah.
Yes, boiling point of solution, which will be equal to 373. This is T naught B. Let me write it like this. I mean, if you see this, this is nothing but T naught B plus delta TB. This is the new boiling point. Huh? And if you have rearranged this, this particular delta TB, if you rearrange this, you will get the same thing. T naught B was 373.15 plus delta TB is equal to 0.052. I just add this and tell me how much Kelvin is that. If we take you have taken, I guess, yes, Ahmed, it's fine. You have taken 373. You have not taken 15. It's fine.
So I said the second answer as well.
You said the second answer as well. Yeah, it will. Yes, kind of right. Yes. Yes, correct. This will be equal to. You can, I mean, you can add it. There is nothing. 373 point. Sorry. 373.202 Kelvin.
Yes,
Correct.
sir.
202 Kelvin. Yes, Amalia, you got disconnected for a while.
Yes, sir.
Okay, did you understand this question?
Yes, sir.
Okay, fine. Okay, fine. We will do one more. We will do one more. Just note this down. If somebody has not noted this down, Ahmed, do you have any question? You are raising your hand.
No, sir.
Okay, fine. And if you are done, then raise your hand. If you're done with this slide, then raise your hand. Okay, Ahmed is done. Okay. Everyone is done. Fine. See once more. Okay, let us do simple one. 18 gram of glucose we have dissolved in 1 kg of solvent. Okay, let us do similar type of question. Similar type of question. Let us do. Okay. Wait a second. Let me do some calculation. I take NaCl, then I want to give you some easy. I mean, you don't have to calculate much. Okay. So I want to give some mass which is added to some mass of water, and it is in some good terms. Okay. Okay, fine. We have the same things. We have just water. Now we have changed the. What do we have? We have changed the solute. We have changed the solute. The question is. 5.85 grams, 5.85 grams of 5.85 gram of NaCl is dissolved in 1 kg of 1 kg of water. Calculate the boiling point. Calculate the boiling point of solution. Okay. Now you know what is the kb of water. Kb of water is equal to. Tell me. Yes, Ahmed, you are unmuted.
0.52.
Yes.
0.52.
0.52 Kelvin. 0.52 Kelvin kg per mole. Kelvin kg per mole. Okay. Now do this question. If you want something, molar mass of any compound here, sodium, chlorine, anyone's, then tell me.
Sir,
Yes, tell me.
TB and T naught B we should take in Kelvin.
TB. What is TB?
100.
No, no, no. I mean, I'm not asking the value. I'm asking what is it for any
Oh,
solvent. If I take. It is
temperature. Boiling
temperature,
point.
boiling point
Yeah.
only, not temperature. So this will be in Kelvin because we have got the KB in Kelvin. We will use in Kelvin only. Okay.
Okay.
Let me do this with you. Delta TB is equal to TB minus T naught B. Now this is equal to KB into M. Now M is equal to molarity is equal to N upon 1 kg. Now we have to find N is equal to number of moles is equal to what? Given mass, that is 5.85 grams upon what is the okay, fine. If you know the molar mass of NaCl, put it in the chat.
58.5.
Yes, correct.
Yes, sir.
Ask chat, but still it's fine. 58.5. This will be equal to how much?
0.1 mole per kg.
0.1
1 mole per kg.
mole kg.
So the
Okay.
previous answer and this answer will be same.
Yes. And that drives the point home now. Colligative properties. It does not depend on the nature of solute. It depends on the amount of solute. And see, what is the amount of solute we are dealing with? We are dealing with the amount which is
1
in
mole.
terms of, yes, moles, the currency of chemistry, moles. Yes, Mariam, did you get the answer? Are you near the
Yes.
answer?
Yes.
Yes, okay, fine. The same thing, which is equal to 0.52 into 0.1. This will be equal to 0.052 Kelvin. Okay, if if we just eliminate all those, we will get 0.5052. This is a delta TB. Then TB will be equal to 373.15 plus. The answer is not that 373.15 plus 0.052. This you will get as 373.202 Kelvin. Okay. Done. Let me know if you're done. Ahmed, you have raised your hand. You're done. Okay.
So
Yes,
I
Sanya,
thought
that
you
is
would
correct.
say raise hand if you got done.
Yeah. Amalia, are you stuck somewhere? Okay, Amalia is also done. Okay, fine. Now let us move on to some different type of questions in which we will play with the formula that we have here. Okay, the formula that we have here is what? The formula that we have here is delta TB is equal to KB into M. Delta TB is equal to KB into molality. Now we can write molality is equal to M is equal to number of moles of what? Number of moles of solute upon the
Solute
mass
upon 1
of
kg of solvent.
kg of solvent, that is WA. Now if I take WA in grams, then I can write this as what? If I want to take this is in kg and I want to convert it into grams. It's in kg. I want to say WA upon WA in grams, then I have to do what? I have to
Multiply
divide this by
1000.
1000, but dividing that by 1000 or multiplying here in the numerator, it is the same thing.
Yes.
You all agree? I mean, if I take like this on 1000, this will be equal to N into 1000 upon into 1000 upon W of A. This is W of A, correct?
Yes.
Now, how can I write N of this is N of B, na? That is the yes, the moles of solute. NB I can write as W of B upon molecular mass of B into W of A into 1000. Yes, Mariam, do you have any problem till here?
No, sir.
No? Okay, fine. So I can write the M molality is equal to this much. Just substitute in 1. What is 1? This formula here, this is set at 1. Now delta TB is equal to what? Delta TB is equal to KB into what is molality? It is equal to W of B into 1000 upon we have the molar mass of B into W of A. So as you can see, delta TB, that is how will you find delta TB? Just imagine yourself in laboratory now. Okay, you have been given a pure solvent, you have been given an unknown salt. Okay, now then they ask just determine what this salt is. Then if you try this formula, for molecular mass, I mean how to determine the molar mass. First we will determine the molar mass, then I will think of a what salt it is. Okay, then to determine it, you have everything. You have KB of water. You want to determine that elevation, then just boil that solution and see at what point it is boiling. Then you will get delta TB, and you have this the amount of solute that you are taking because you are the one who is going to boil it. And then you have the mass. Sorry, that is the this is what this is the mass of solvent. So by this also you can determine the molecular mass. Okay, so this will be equal to, now if I write MB is equal to, MB will be equal to what? MB will be equal to KB into W of B into 1000. Now just remember this 1000 when I am taking, I am writing everything is in grams. Okay, everything is in grams. KB upon this is delta TB into WA. Delta TB into WA. Okay. Now I should
So
say
why
that
is it
say that.
capital and small b?
Sorry, can you repeat that? Why it is?
Here you used over here you used capital and
Okay. Now WA, comma WB, comma MB are all in grams. Okay, everything should be in grams. Now what is the topic? I can write that. This is determination of molecular mass or molar mass by elevation in boiling point. Okay, fine. Just note this down. Raise your hand when you are done. Am I done?
yes.
Okay, let us do one question. We have here, what do we have here? 36 gram of our non-volatile, 36 gram of a non-volatile, 36 gram of a non-volatile solute was added to, added to 1 kg of water, 1 kg water, which increased, Sanya, you can lower your hand, which increased, and let's write it like this, wait a second. The boiling point of the solution, was found to be, let me make a calculation, was found to be 373.254 Kelvin. The boiling point of the solution was found to be 373.254 Kelvin. What will determine the molar mass of solute, and guess the compound. Okay. So you have what? You have been given the boiling point of solution. It is obviously increased. First we had water. So we just write what are the givens here. The delta T naught B is equal to what? 373.15 Kelvin. Okay. Then we have TB is equal to 373.254. Yes, tell me. Did somebody say something? No.
No, sir.
Okay. Kb is equal to 0.52 Kelvin. Kg per mole. The previous term, because we have what? The same thing, water. Correct? Same thing, water. Okay. Then we have what? 36 gram of non-volatile solute. Solute is shown as WB. It is given as 36 gram. And WA, it is given as what? WA is given as 1000 grams. Remember that if you are using this formula, then you have to write what? In grams. Everything in grams. Okay. Now you have got everything. Okay. Tell me how much is delta TB? Yes, tell me.
Sir, in question, TB is not given.
TB is not given.
Yeah.
TB is still given, the boiling point of solution. You're telling me T naught B is not given?
Yeah, T naught B, sorry.
T naught B is not given. Something is missing. Something is missing?
Yeah, it is not given in the question.
It is missing, na?
Yes.
Is it missing? Everyone, raise your hand if it is missing.
No, sir, it is not.
Raise your hand. Somebody's brain is missing. What is the Maria? Sorry, Sanya. Sanya, can you please unmute? What is the solvent? What is the pure solvent? Are? You are unmute, but you are not speaking.
Sir, how you got KB?
Water, na? We are using KB from the previous. So it is water only, na? See.
Oh,
From
okay.
here, KB, here also KB is same. Here also KB is same. I'm not writing KB for water. See, KB for water is equal to 0.52. I'm just putting this because if you know about water, na, that is the most frequent solvent that you will be getting in exam. Now, if you don't get KB for water, then what will happen? You will remember it 0.52. Okay. Yes, Sanya, I asked you something.
Yes, sir, it is 373.15.
Why it is 373.15?
I don't know.
You don't know? Tell me what is what is T naught B? I'm not asking how much. I'm asking what is it? What does it show? Does it denote?
It's the pure boiling point.
Pure solvent's boiling point. What is the
Yeah,
solvent? What is the solvent? Can you see what is the solvent? Read the question, the first line. Just the thing before the full stop.
It is 1 kg,
Of what is the solvent?
36 gram of
I am not asking how much. I am asking what is it? What is the solvent?
solvent is the water,
So what is the boiling point of water?
373.
I mean, it is 100 degrees Celsius. Na? I hope you know this. This is the
Yes,
boiling point
sir.
of water. Okay.
Yes,
So
sir.
they will not give you exactly if it is water, they won't give you T not B. Okay.
Okay, sir.
Boiling point,
Okay.
because you have to know point of water. Yes, Ahmed, that is correct.
Sir, we
What
have
is
to
correct?
find WB or MB
You have to calculate
or
the
both.
molar mass of solute, na?
Okay, sir.
Calculate the molar mass of solute. Now, all of those who have found TB, delta TB, if you have found delta TB, raise your hand. Delta TB is nothing but TB minus T naught B. Okay, everyone. Sanya is remaining. Sanya, please calculate it. Okay, and just post on the chat how much you have found delta TB. Ahmed has already given the answer. You can lower your hand, all of you, and write in the chat. Just write the value. Yes, correct, Amalia. That's right. No, Mariam, that is wrong. I mean, that is wrong, Mariam. See how many digits are there after the decimal point in T naught B, and see how many digits are there after the decimal point in TB.
1 second.
Okay. Sanya, did you calculate TB minus T naught B, delta TB? Guys, you have to be fast. How you, Sanya? What is TV? 373.254 Kelvin minus 373.15 kelvins. You just have to subtract it now. Okay, ignore this. You have to ignore this.
Got it. It
Got
is
it?
0.104.
Yes, 0.104 Kelvin. Now, Mariam also got it, 0.104 Kelvin. Okay. Now you have TB, right? You have everything. You just put it in this formula. Okay. Put it in that formula. You will get MB. Really, that much? Let us see. KB WB 1000. Into 1000 upon delta TV into, what do we have to multiply this with? W of A. Now this is KB is equal to how much? KB is equal to 0.52 into
into
1.
36
Into WB is 36. This is into
into
1000 upon delta TB is
0.104
0.104 into what is
into
WA?
1000.
Into 1000.
1000.
Yeah, so this
1000
is
cancel out.
this will be divided by 2 now.
Yes, sir.
So how much is the molar mass we got?
18.3.
Did I miss something?
So 18.
18.
Yes, sir.
18 grams. Okay, fine. Hmm. Did everyone get the answer? Sanya is getting 180. Okay. Did I miss something? I guess I 0.52 thousand dB MB is equal to.
No, sir, it's all right.
It's all right.
Right. Yes, sir.
Yes, Amalia, you have raised your hand. You want to say something? No. Okay.
No, sir.
Okay. 36 gram of non-volatile solute was added to 1 kg of water. The boiling point of
Sir, I am also getting 180.
180. Okay. I mean, I made it such a way that it should be 180. I'm guessing, did I?
So it is 0.2. No. Yes, sir, it is 0.2.
Sir, 0.14 you cut with 2. It should be 0.2.
0.2. Yeah, that should be 0.2.
Yes, sir.
0.2.
So 1.5 is bigger than 0.104, right? So
0.2. Yes. So you will be getting 180 grams.
180.
Now, 180 grams is correct. 180 grams. Now, can you guess what is this? What is this?
Glucose.
Glucose. Correct.
Okay.
Glucose. Okay. So nothing happened. I just doubled the mass of glucose and I doubled the elevation. Right? Now you got the idea how to do
Yes,
this.
sir. Yes, sir.
If everyone has got the answer, raise your hand. Raise your hand if you have got the answer, and if you want to move on. Yes, everyone has got the answer. You want to move on now. Similar type of question. Let us have. Okay, I guess osmotic pressure will not be done. I mean, it is important to do some problems because otherwise, what is the use if you will get stuck in problems? I hope you will do this fastly. I mean, faster than the previous questions. Faster than the previous question. Now, can somebody tell me the boiling point of benzene? Can somebody, if someone is in laptop or something, then can they?
353.23.
Oh my God, you remember that?
Sir, it is in the book.
So it is in the book. Boiling point of. And this is one of the solvent that we use majority of the time in. See, we use water, H2O. We use benzene. Then we also use toluene. I mean, these are the most very frequently used solvents in the chemistry lab. The boiling point of benzene is 353 point. How much? 353.23
23
Kelvin.
Kelvin.
Okay. Now let us add. Okay, fine. The kb of benzene. The kb of benzene is, now I remember the kb of benzene. It is 2.53. kb of benzene is 2.53. The you will be kilo Kelvin kg mole inverse. kb of benzene is 2.53. Okay. Now I have to give you something so that it will be easy for you all to calculate. It will be easy for you all to calculate. So let us do one thing. Let us keep it 2.5. Let us keep it 2.5. The boiling point is itna kb of benzene and it is 2.5. Okay. Now what should I do? Fine. 2.5. Then I will get like that. Okay. When a non-volatile solute, when a non-volatile solute weighing 5 grams, was added to benzene. The boiling point increased. Wait a second now. We have got what? We have got KB, and we have got KB. We have got KB, and we have got WB, WA. Okay, fine. Added to benzene, the boiling point was increased to. Okay, increased by. It was increased by 0.5 Kelvin. 0.5 Kelvin. Okay, is anything solute weighing 5 gram was added to? Let me write benzene, the WA. I have to write WA. Let us take 1 kg. 1 kg benzene, the boiling point increased by 0.5 Kelvin. Okay. Is anything left? Do I have to give anything else? No. I have to give the question. Calculate molar mass. Calculate molar mass of solute. Okay, let's do this. Do this problem. Let me know. I mean, delta TB is given directly, so you don't have to write TB and everything else. Delta TB is given. It's almost 0.5 Kelvin. Then we have KB is equal to 2.5 Kelvin kg mole inverse. Then we have got W of B, which is equal to 5 grams. We have got W of A, which is equal to 1000 grams. Okay. Now we have got what? We have got molecular mass of A. Do we need molecular mass of A? I don't think we need molecular mass of A. We just need the molecular mass of B. Calculate this. Let me know what is the answer. MB is equal to 1000 into what? W of B into KB upon delta
Sir,
TB.
25.
Okay, Sanya, yes. Okay, fine. I don't know. Wait a second. I guess you're right. Delta TB into W of A. Okay, Sanya has given the answer, and Ahmed has also given the same answer. So I guess it is right. Amalya has given the answer, but it has some. No. I mean, it is different. 1000 into W of B is 5 grams into KB is how much? KB is 2.5. Then upon we have delta TB 0.5 into 1000. Okay, now this 1000 will cancel each other. Whatever we will be getting in gram mole inverse. Let me just erase this gram also, because I have written everything in. Now this will be equal to 5 tens of
25.
25
grams
grams.
mole inverse. Amalya, did you get where you went wrong?
Yes, sir.
Okay, fine. Everyone got the answer now. Now let us move on to the next concept, that is depression of freezing point. The next point, that is depression in freezing point. Depression in freezing point. Depression in freezing point. Okay. Now, unlike boiling point, the freezing point does not have an external indicator, right? I mean, the boiling point depended on what is the atmospheric pressure, correct? But freezing point depends on the freezing point. It depends on what type of compound do you have, what type of molecule do you have when it starts to pack, and that is why what happens. We have this particular graph. Now it is known as phase diagram. It is known as what? Phase diagram. It tells us at what temperature, what will be the at temperature and what pressure, what state of the compound will be there. Okay, so for water, it is generally like this. And then we have kind of a straight line. Like this. Okay. So what does this determine? It says that this is liquid. Okay, this is solid. If you are here, then it is solid. And if you are at this point, this is gas. This is what? This is gas. Okay. Now this is liquid, this is solid, this is gas. Okay. Now if we just remove this gas here, okay, we just remove this point, all these notations here, okay, and let us look at just this, which is solid here, which is the solid, this is frozen. This is frozen, and this is what? This is liquid. This is frozen, this is liquid. Okay, and we have temperature here. Okay, and we have vapor pressure here. So the same thing happens as we saw in our. Now this black is for pure liquid. In boiling point, we saw the same thing, pure liquid, and we will do this green one. I guess that was green. Green is for solution. Green is for solution. Now at a particular temperature, the vapor pressure of the solution will be lower, and hence it will follow this curve, the same type of curve. The curvature would be same, and hence it will be freezing at lower temperature than the pure one. Now this is freezing at this temperature. Okay, and our pure solvent was freezing at this temperature. Now this will be known as what? The TF, because it is for solution. Let me just write, this is for solution, and this point will be known as T0F. This point will be known as T0F. Okay, and this difference here is what? It is delta TF. So delta TF is equal to, what is more here? Yes, Ahmed. What is more, TF or T0F?
T0F.
Yes. So T0F minus TF, because difference is always positive. Okay. The result for subtraction can be different. It can be negative, but if you ask difference, what is the difference between 5 and 3? You will always see it is difference of 2. Between 5 and 3, the difference is of 2, and between 3 and 5, again the difference is 2. It is always in positive, delta TF. Now T0F into M, and we have found same thing experimentally. We found that delta TF is directly proportional to the molality. Hence delta TF is equal to Kf into small m, when same thing, when m is equal to 1, delta TF is equal to Kf. Hence it is what? Kf is the molal. Let me write first the statement clearly more. Kf is the depression in freezing point. Depression in freezing point when the concentration of solution is how much? Yes, Mariam, concentration of solution is
100%.
1
100%.
molar.
I said 1 molal.
One more.
1 molal. Okay. Now, hence this will be known as what? This will be known as the molal constant. Molal constant. Molar constant or molar depression constant. Molar constant of depression or molar depression constant. Molar depression constant. Okay, let us look at it again. When we have pure liquid, the vapor pressure is more. When we have solution, the vapor pressure is decreased. Now, as we decrease the temperature to form a frozen solvent, or when we want to freeze it, the liquid will freeze. The liquid, that is the pure liquid, it will freeze at a higher temperature. Okay, it will freeze faster than the solution. It will freeze faster than the solution because the solution has what? Because the solution has low vapor pressure. It has low vapor pressure. Okay. If you have any doubt, raise your hand, and if not, then write this down. Okay. Yes, Ahmed.
So what about supercooling?
What about
Supercooling.
supercooling?
Yes, sir.
Supercooling will happen if we just don't get a freezing point, and the solution is the liquid is freezed so fast that without achieving this point, what happens? We just destroy this point and we go ahead. Okay, supercooling happens when we cool it very fast. We don't follow this path. If we don't follow this path, then what will happen? We will have liquid even after the point is missing. Even after the point
Freezing
is
point.
even after the freezing point is missed.
Okay.
Have you ever prepared crystals and all?
Yes, sir. Like I even made a presentation on that last year.
Okay, you have made crystals?
No.
So you haven't made crystals. Okay, so when you make crystal, now you have you boil few things with each other. Okay, you boil few things with each other, then you have this hot solution in which there will be some crystal have to be formed when you cool it. So if you have to cool it, we take a tub type of thing. We take a tub type of thing, and then we put ice in that. When we put what? We put ice there. We put some ice here. Okay, now some students, what they do, they are very excited and they put so much of ice in that tub that it starts to cool very rapidly. Now when it starts to cool very rapidly, this crystal, when it was supposed to reach its freezing point, it misses its freezing point and it has a lower temperature than its freezing point, right? So what happens? They don't get any crystals. You have to cool it very slowly. Okay.
Okay, sir. So done.
What about others? Done?
Yes, sir, done.
Okay, done. Right. Now tell me, you have to show the relationship between, just as we did here, determination of molar mass by elevation in boiling point. You have to tell me determination of molar mass. Same thing, determination of molar mass by depression in freezing point. Now, if you are done with what will be the molecular mass by depression and freezing point, let me know. Raise your hand. Raise your hand if you get the expression. You have to derive it. You have to derive it as we derived for the boiling point. You have to derive it. Sania is done. Okay. Ahmed is also done. Amalia and Mariam. Okay, fine. Just relate whatever the terms are in depression and freezing point and elevation in boiling point.
Sir?
Yes.
Sir, we have to write the answer in the chat box.
No, can you write the answer in the chat box? You can
No,
write
sir,
it
it
like
is
this.
good.
You can write it like this. Nu, you will write NUM. Then you will write all the terms which are there in numerator. Then write
Okay.
DAN. You can write it like this.
Okay, sir.
Okay, Mariam is remaining. Mariam, are you having difficulty or you are not trying, right? Acha, Mariam also got. Okay. If everyone has got, then okay, fine. Don't bother writing in the chat. I am writing the answer here in the screen and just compare it. Okay, just compare it. You will have first of all, and everything is in grams, right? Everything is in grams. So you will write 1000 into 1000 into. Okay, fine. Tell me, Ahmed. Tell me what another term. What is in numerator? One term, only one term. Tell me one of the terms of numerator.
KF.
Okay, fine. KF. Okay. Now, Amalia, tell other term in the numerator that you have.
WB.
WB. Yes. Now, Sania, tell me the first term in denominator.
Delta TF.
Delta TF into. Now, last, Mariam.
WA.
WA. Okay. So you have got the how to determine the expression, the relationship between the depression in freezing point and the molar mass. Depression in freezing point and the molar mass. Now let us do a question. Let us do a question. Okay, let us take the same type of question that we did. Okay, same type of question. Now KF, we want to know the KF. Okay, we want to know the KF. Fine. 45 grams. 45 gram of ethylene glycol is mixed in. Just take 300 grams of water. 300 grams of water. Okay, you have to calculate. Okay, one more thing that I have to give is that is the TF, right? You have to give the TF, right? TF of water. TF of water is 1.8, I think. TF not KF of water. What is the T not F of water?
1.8.
1.86.
No, I'm asking T not F.
Okay.
KF of water is
373 degree.
again once again,
373.17 Kelvin.
again it is TF. F is okay. KF of water is 1.86. 1.86. Okay, KF of water is 1.86, and you have to calculate what? You have to calculate. You have to calculate the depression in freezing point. Freezing point of water. Okay, and also remember, guys, you have to know these all terms now. What is T naught F? T naught F is the
Delta
FPT
TF.
of freezing point of.
Pure,
No, it is freezing point of, yeah, freezing point of pure solvent.
pure solid.
And what is TF? TF is equal to FPT, that is the freezing point of solution.
Solution.
Okay, just remember this. Okay, can you do this all? This is easy.
Yes,
Yes.
sir.
The molar mass of
Okay,
ethylene
do you know what is
glycol.
ethylene glycol? What is ethylene glycol?
Yes, sir, we don't.
Don't know. It is this guy. Ethylene, no? Okay, I guess. And OH.
So
What is
your
this?
voice is cracking. We cannot hear you.
Is it the same for everyone?
No, sir.
No, sir.
Ahmed, you have got a problem. This is what C2, and here will be hydrogens. Here will be hydrogens. How many H? H6, O2. This is ethylene glycol. Let me know if you get stuck somewhere.
So what?
Did you get the molality?
Yes, sir.
Okay, how much is the molality?
No, sir. Yes, sir. Yes, sir. 4.4. 4.46.
Can you please write in chat? I could not hear it properly. Can you write in chat? What is the molality? How much it is? Correct. Amalya, I guess you have rounded off a bit. I guess this is your answer for now. No. Sorry, no. Amalya has not. Amalya has different answer. Okay. Yes, Sanya, that is correct. This 2.4. Okay, Amalya has left. Mole disconnected per kg. Everyone, did you get this answer? Okay, Amalya is here. Ahmed was okay. Ahmed left. Ahmed was disconnected. Sanya, I cannot understand what you have written here. Delta TF is equal to now what? KB. What is KB here? KB is given as 1.86 into 2.4. This will be in Kelvin. This will be in Kelvin. Okay, I'm admitting Ahmed, but Ahmed is not. Okay, fine. Okay, fine. Two devices. Okay. Delta TF. How much is this? 1.86
So I'm
into.
using one.
You're using one device. Okay, I can see two Ahmed here.
Yes, sir.
Okay.
So even I can see, but I'm using one device.
Okay. It's fine. Sanya has written some things, but I am not able to understand it.
Sir, that is T.
Yeah.
You have written T naught F.
Sir.
T naught F is not that much. Tell me how much is delta TF? Did anyone get delta TF? Raise your hand.
Pretty fast.
Sanya got
4.5.
delta. Sanya, what is delta TF?
Sir, it is 4.46.
4.46. Okay. 4.46 Kelvin. Now, what is the depression? Now this is delta TF. So what is delta TF? Delta TF is nothing but delta TF is equal to T naught F minus TF. Now what is T naught F? What is the freezing point of water? Because you have solvent now. Water is our solvent.
273.
273.15.
Yeah.
273.15 minus
Minus
TF. Now this will
2.4.
be equal to 4.46,
Okay.
right?
Yes.
So TF will be equal to what? TF will be equal to, now I will move this here and I will have 273.15 minus 4.46. This will be equal to how much? Tell me. Okay, you have given that answer. Okay, I get it now. Now that is not T naught F, it is TF. Now, Mariam.
Sir.
Yes,
Yes.
sir.
Sir.
Let me wait a second, Ahmed. Did you get any answer, Mariam, or no answer?
Yes, sir, I got
This
it.
form.
That formula? Yeah, what is the problem in that formula? Yes, correct, Sanya. I just wrote the first formula, delta. Okay. You're saying about this B, na? It's KF into M. Sorry for that. It's KF
I
into
did
M.
not use the formula.
I did not use the formula. What are you saying? Your voice is not audible. Your voice is cracking. The answer is 268.69.
So I'm saying I did not use that formula.
Then what did you use? What formula did you use?
I used the one multiplying with 1000 directly.
The one multiplying with 1000 directly.
Okay.
Okay. Yeah, that is also fine. I mean, this formula which was written here, no? That is also
Yes,
fine.
sir.
Okay, that is also fine. No problem here. So you found delta TF by this formula. I mean, it would be a
Yes,
bit
sir.
tough.
No, so it was like
It was
the
fine also.
values were given directly.
Okay, the values you
I
had
got
put in.
4.5.
Okay. You got the answer. This answer 268.69.
Not exactly,
Then
but
how
it
much
is
did you
near
get?
to.
I guess you took this as 4.4. Delta TF as 4.4. Am I right? Okay.
So I got 68.65.
68.65.
I took it as 4.5.
So you took it as 4.5. Okay, fine. Okay. All of you have, if you have got this answer, please raise your hand. This answer or near to this answer. Okay. Ahmed has got the answer. Mariam, you haven't got the answer?
I got it.
Got it? Okay. Let us do one more. Okay, now let me see this question once again. KF. Now we will find the molecular mass. We have got KF, we have got WB, delta TF, and WA. Now I have to have some kind of good relationship between Kf. Kf is how much? Kf of water is 1.86. Now 1.86. Okay. 1.86. Fine. WA and WB. Okay. WA and WB. Just take 10 gram of non-volatile, 10 gram of non-volatile solute was added to 1 kg of water. Added to 1 kg of water. Was added to 1 kg of water. The solution formed. Had freezing. The solution formed. The freezing point of solution. The freezing point of solution was lowered by, wait a second now. It was lowered by 3.72 Kelvin. It was lowered by 3.72 Kelvin. Kg of water, you have kg of this. You have to calculate the determine the molar mass. Determine the molar mass of what? Molar mass of solute. Okay, molar mass of solute. Now, what is Kf of water, Ahmed? What is the Kf of water? Can you see the previous question? We had water only. What is the Kf of water? What? I could not.
So my net is.
Your net is okay. Fine, I won't ask. 1.86. 1.86. Okay. Solve this and let me know what is MB. 1000 into how much? 1000 into Kf into W of B upon delta TF into W of A. This is an easy one. Amalia has got an answer.
So
We
far.
will see. Let us see. If you have got the answer, raise your hand. Amalia has got the answer, yes. 1.86 into W of B, which is equal to 10 grams upon delta TF is 3.72 into W of A is 1000 grams. I guess, Amalia, you missed this point.
Yes, sir.
And this will be equal to what? 5 grams. Okay.
Yes, sir.
Mariam and Sanya, did you get this answer?
Yes, sir.
Yes,
Okay.
sir.
Now the last point is see, KF and KB, both of them depend on what? KF and KB, both of them depend on the nature of KF and KB depend on the nature of solvent, on the nature of solvent. Okay, on the nature of solvent, and they can be calculated. They can be calculated by the following expression. By the following expression. Okay. Now what is KF? What is KF? KF is equal to R into molecular mass of the solvent, that is Ma. We are writing it as Ma into the T naught F, the T naught F square, the T naught F, or you can write T naught F, that is the pure solvent, squared upon, we have 1000 into. Now since we have freezing, we will write delta H of fusion. Okay, what is delta H of what is fusion? Fusion is what? When we have liquid and solid in equilibrium, delta H fusion. Okay, and this Kb is equal to same thing, which is R into Ma, okay, into T naught B squared upon 1000 into delta H of vaporization. What is vaporization? Vaporization is when we have liquid which is in equilibrium with, vapors, which is in equilibrium with vapor. Okay, just note this formula in your copy. I mean, I haven't seen any questions from this formula as of yet, but you never know. Okay, you will be given. Now what is R here? What is R here?
Yes.
Universal gas constant. Okay, now R is equal to gas constant. Now what is Ma? It is the molar mass of solvent. Okay, and T naught F and T naught B, it has the same work as we had in previous. It is a notation for the freezing point of pure solvent and the freezing point of, boiling point of the pure solvent. Note this down. Let me know when you are done.
So done.
I'm done. Okay. Others, raise your hand if you are done. Ahmed is done. Amalya done. Amalya is writing, I guess. Okay. So, do you have any doubt till here?
No, sir.
No, sir.
No? All of you? Amalya, Mariam?
No, sir.
No? No doubt?
No, sir.
Fine. Can we discuss about that Ramzan timing now? Because I guess Thursday will be Ramzan for sure.
Yes, sir.
Okay, fine. Your class end on 12 noon.
So they have changed the timing. Now
No,
the
sir.
class is starting 8:35.
In the morning,
Yeah,
Yes,
and
sir.
it is ending at.
that we don't know.
Okay, previously when did it start? At what time
It
the classes were
started at 8.
started at 8?
Yeah.
Oh, I guess they have just shortened the time because of Ramzan. I guess you will be ending at 12 only. I guess that because in Ramzan nobody will take longer classes than non-Ramzan days, no? I mean, They can take the same duration of classes, but they won't take more. So I guess at max you will be free by 12:35 p.m.
Yes.
Right? If right.
Free by 12
So
or
yes, Ahmed,
12.
you are saying something.
So we'll be free by 12 because we won't have break time. No
So
one
you
will.
want okay. I mean they expect everyone is fasting.
Yes,
Okay,
maybe.
yes. Okay, fine. Wait a second. 12:35. Then I have to add here. This to be 2 o'clock. Then can I have, what is a good point? You have Thursday and Sunday. So Sunday is free for me and Thursday is also now it is free for me. So I can take early classes. Now previously I had my classes in my college. Now I can take on Thursdays also because the syllabus is almost over for Thursdays. Then can I take from in your timing? Can I take from 1 p.m. or will it be too much to ask?
Yes, sir, no problem.
Yes, sir, no problem.
So
No
we will
problem.
break for a little while.
Sorry, what is he saying?
So we will need a break for a little while.
So you are okay. You are getting a little
Minute?
while now.
Yes,
How
sir.
much is little while? 1 hour?
Yes, sir, at least.
Oh my God, 1 hour.
Yes, sir.
What you will do?
Sir, it's okay, 1 o'clock.
Okay, fine. Ahmed, I am doing this 1:15. Okay, don't. I mean, if you will have 1 hour, you will probably sleep. Let us give it 1:15. Okay.
So
So
I'm
1:15.
saying for our good, like, firstly will be like empty stomach, and then we'll have to think a lot while doing and understand as well.
But I mean, we
The
are
day
doing
just
nothing.
started.
You are doing nothing from 8 to 12 now.
So classes,
So are you doing something in classes or you are just listening?
no sir, we have to write, we have to understand, we have to.
Mariam, tell me.
Sir, there is
Are
no
the
hard
classes,
work. Nothing we have to do. Just listen and note down little work. That's
those
it.
classes are not engaging, na?
No, not too much.
That's it, na? See, it's just okay. So 115 is fine. Now wait a second. Now 150. Wait a second. Okay, no, not 115 is fine. 115 will translate. Yes, Ahmed, do the translation for IST, Indian Standard Time. In India,
So
it will be
2:45.
2:45.
Yes sir.
That means I will be ending the class at 4:45.
Yes
Correct?
sir.
Okay. 2:45 to 4:45. I hope you are correct, yeah. I mean, I don't want to be messed up. Wait a second. If it was 1, it would be
No, it would be, yes sir, it would say it is
hmm,
correct, I
it
guess.
is correct.
I guess.
2:30, na? We have a difference
No,
of
it will be
2:30.
3:30 sir, it will be 3:30, 3:45.
3:45.
3:45 to 5:45.
Pakka.
To 5:45.
115 may add, I have to add how much?
2.5 hours.
So it will be
3:45
3:45 to
for 5:45.
5:45. Acha. Now you tell me, 2 hours is fine for you all
Yes sir.
Yes, sir.
in Ramzan also? Okay,
If
fine.
you
We will.
can, then no problem.
What?
We are
So if you
used to
can
it.
make it less, then it's fine for us.
Okay, fine. Okay, I mean, I will also see 2 hours now, and this will be the peak hours for me, right?
Yes sir. Like